Next, I'd like to show how the inductance L depends on these variables. Let's start off by looking at mu, the permeability constant. Now, here I have an inductor, and it's connected up to this inductance meter, and it's reading an inductance of 0.107 millihenries. Right now, the coil is empty, it has air in it, and the permeability constant for air is essentially the same as that for empty space. And so that gives this particular value of inductance when we put that combination together. Let me put a piece of wood in there and see if that changes the inductance. And it looks like the inductance is staying essentially the same for wood. So wood has the same permeability constant as does air. Plastic, essentially the same. So plastic and wood have the same constant. Now let me try a piece of iron. Here's a rod of iron we'll put down in here. And notice how that increases the inductance as we put in iron, which has a fairly large permeability constant. And we see that that increases the inductance now up to a value of 0.218 millihenries. Notice as I pull the iron out that the inductance will decrease. Depends on how much of the core is occupied by the iron until we get back to the original value. In fact, it occurs to me if I take a little alligator clip here, which has some iron in it, and put that down the coil, let's see what that does to the value of the inductance. Increases the inductance up to 0.120 just by putting that little alligator clip in there. So depending upon what's inside the core, the inductance will change, and the inductance depends on the permeability constant as well as these other variables.